Hi, in this segment, I'm going to compare integer types with character type. Character is actually treated as a special type of integer. However, there are some minute differences between int type and char type. Okay, that's what I'm going to show to you in this segment. In the previous segment, we saw the first two um, functions. We looked at the disassembly and we saw there's no difference between int I or unsigned int I in terms of arithmetic operations like +1, for example. Okay, the assembly code looks literally the same. For example, we saw disassembly of int I is exactly the same of unsigned I, no difference whatsoever. Okay. In this segment, I'm going to take that to the next level to show to you the third function, increment a character by one by value of 1. I will show you that it is slightly different. Okay, and I will talk about the difference in the segment. Okay, so as we can see, it's not really the same as the inc I or inc unsigned I. It has some more instructions, right? But the interesting point is it still has the same add instruction. Okay. So I'm going to explain to you what is the meaning of move zbl, what is the meaning of move al to 0 minus 4 EBB. So I'm going to explain those two. However, before going to do that, I will first explain the meaning of move zbl and move sbl. Okay, that's the reason I build a small program which will hopefully help us to understand the inc C more clearly. Okay, so let's start with the first demo. The demo is to show to you. Here is a simple function, right? Demo1 function. What is happening here is interesting. We have a character C assigned to some value, right, in hex value. We are returning C to the caller. Okay, what is the data type of C? C is a character type, but the function signature says it's going to return int type. So how does the assembly code handles that difference? Okay, let's look at that. Disassemble demo underscore 1. So what we are seeing is pretty interesting. The first two lines and the last two lines are standard stack setup and termination code whenever you call a function. So I will focus only on the main aspect of the conversion part, right? Converting the character. How are we handling that? Okay, so the part that is interesting is move b. Okay, what is the meaning of b? B means in this case byte. Move b means move a byte. Which byte are we moving? We are moving a byte called f0 byte, right? F0 is 1 byte of hex value. We're moving into a particular memory location. That memory location is referenced using EBB -1. The reason why we put -1 is that character type requires only 1 byte. Okay, that's the reason we are doing move b the hex value of f0 into EBB -1. Okay, what is the next statement we are doing? The next statement is we take the current EBB -1, which is basically the location that has this value f0. We don't send that as it is to the caller because the type is integer type. What are we trying to do in that case is we take that value and we do sign extension. Okay, the meaning of SBL means copy the byte from EBB -1 to EAX. That means only 1 byte is copied, right? What about the remaining 3 bytes? Because we have an L here, L means long. The remaining 3 bytes will be signed bit, okay, extension. S means signed bit extension. So we'll be sending to the caller FFFF0. Okay, that's what we're going to send it to the caller. Let's do a demo now. Run it and put a breakpoint. Okay, so I'm going to put a breakpoint at where? At say at this location. Okay, so to show to you the value of EAX, how that is changed. Okay, so I'm going to run this. Okay, and now we will be looking into the status of the EAX, right? I wanted to show what is inside the EAX first. EAX has some value. We don't know what that is. Don't no worries about it at this point. And we are going to now execute the next statement, right? Move EBB -1, the value into EAX, but we will also do sign bit extension. Okay, so just to be clear, I will also show to you the value of EBB -1 at this point. EBB minus 1, right? Okay, what you're seeing is we have to examine the value, right? Examine, say 1x byte, 1 byte of EBB minus 1. Okay, what we are seeing is interesting. We're seeing F0. That's exactly the value we have here. F0 is the value we have here. Okay. And now we are going to, what is the next statement we are going to run? We can examine the right print dollar or we can do examine EIP, which will show us the next instruction we are going to execute. That's the exact instruction we want to execute. Let's move forward with one instruction. And now let's look again the status of the EAX register. Okay. What you see now is that F0 is here, but the remaining bytes are all changed to FFF. The reason is that if you recall now the disassembly of demo 1, what we said earlier is that move SBL means transfers this byte to EAX register, okay, but fills the leading 3 bytes with the signed byte of EBB minus 1. Okay, what is EBB minus 1 pointing to? It was pointing to F0. The leading byte is F. F means 1111 in binary. So it's going to repeat the ones in all the remaining 3 bytes. That's the reason why we have seen the EAX status change to bunch of Fs followed by F0. Okay, so just to make sure you get this point across, we have F0, right? F0 is just only 1 byte, but we need to send our return value via EAX register. So we need to fill up 4 bytes. So what are the 4 bytes we are going to fill up? We are essentially going to fill up like this. We put F0 for the first byte, for the second byte, third byte, and the fourth byte, right? So we have 4 bytes we need to fill up. So how are we going to do that? So we will take this F and we repeat. F means in binary 1, 1, 1, 1. So what is the signed bit? The signed bit is the most significant bit. So we're going to just fill up the 1 everywhere. We don't need this. Sorry, this is not needed. So we just need 1, 2, 3, 4. Yeah, we do need. I'm a little confused. Okay, we do need 4 boxes. Okay, so this is the byte 1. So we will repeat 111 everywhere, right? 1111. That means nothing but FF in hex. So I will write it as FF. That way it's clear. Hopefully what I'm doing is FF here, and then the FF here, and the FF here. Okay, so this is the reason why we are seeing FFF F0. That's because of this move SBL. S means the sign. The signed bit is repeated to fill up the remaining 3 bytes of the EAX register. Okay. All right. Hopefully this is clear now. How the assembly is generally, how the assembly works when we return, or how the computer program works when we return a character type to the caller. Okay. Remember, the integer types are all the same, character or unsigned, or they're all treated same. They are just called integer types. That's the reason. So we use this trick of a signed bit extension, or 0 byte extension. That's something that I will talk about next. So at this point, I hope that you got the clear idea of move SBL, what the purpose of move SBL. Okay. Now let's move on to the next demo. The next demo is about a scenario where you have an integer I, okay, which is made of 4 bytes, right? 1, 2, 3, 4 bytes. So every 2 characters is 1 byte. So we have 4 bytes, but we are returning only a character type to the caller. So what happens in this case? Let's look at the assembly code now. So I will be disassembling demo 2 and show to you what's happening here. So as always, I will be leaving out the standard setup code and the termination code, and the stack pointer is just adjusted to create room for the local variables. So I will focus more on the main theme of this function is to initialize the value to a particular local variable, right? That's the reason why the same value is transferred to EBB minus 4. And we transfer that EBB minus 4 to EAX register, okay, as it is. So surprisingly, there is no change. What we are sending to the caller is not just 1 byte. We are sending to the caller all of these values. Even though the function signature says we are returning a character type, we're actually returning 4 bytes to the caller because our values are, the return value is stored in the EAX register, okay? So let's do that. Let's confirm by putting a breakpoint, right? Let's put a breakpoint at this location, right? And let's continue our execution. And now we hit the breakpoint. We will look at the state of the EAX register, okay? What you see here is exactly the value that we are going to return to the caller. Although we say we are going to return a character, we are actually returning 4 bytes, which is quite unusual, okay? But that's how it works. All right, so let's do one more thing. Let's go back to the caller. Caller is the main function, right? We are calling at this point. Let's look at the state of the EAX, and we can be sure that it's not any different from what you're seeing here. It's exactly the same. Let's do that. Okay, so what I'm going to do is I will step instruction leave, right? And ret, those are the 2 instructions we need to execute. And now we are back into main. As you can see, we are at main. We can now look at the state of the EAX register. It's exactly the same. It's really interesting that even though we say we are going to return a character, the program actually returned an integer, okay, 4 bytes integer. This last statement has no effect essentially, same as saying return I, okay? That's the main message I would like to get across. All right, the third type now. Let's move on to the third part of the demo. Here we are having a character which is initialized to FF, only 1 byte, right? 2 ASCII characters, FF means 1 byte. The value that we are going to return to the caller is coming from the function inc, which is something that I would like to talk now. It is incrementing the value c by only 1 byte, okay? So now let's pay our attention to that particular program. How is this going to work? Okay, so we'll have to digest the inc now. It's time for us to do that. Disassemble inc I for a moment. Let me clear this. And I'll also show you the inc C so we can compare. In the inc I, our argument was an integer, right? But in inc C, our argument is a character. So how are we treating that different? Okay, here comes the difference. We take the first argument in this segment, right? 8 plus EBB means the first argument to our function, which gets transferred to the EAX. So EAX would have 4 bytes of values, right? Whatever that is, we don't know at this point. We do know the caller has put FF as part of the least significant byte. So we should be able to see the caller and see what happens. Let's look at the caller. Demo _3. Okay, the caller did something useful. First thing he does, he has actually transferred the byte FF. FF is only 1 byte. That's why you're seeing a B. B means move a byte to EBB minus 1 because it's a character type, right? And then he does sign byte extension. Although our inc C is expecting a character type, all arguments are also EAX are also passed as 4 bytes. Okay, that's the reason why we are using a L here. L means long, right? 4 bytes. Move sign byte extension. That means the value the caller is passing to the function inc C is actually all FFs, all 4 bytes made of FFFF. We can confirm that. Okay, let's do that. Other than that, the rest of the statements are similar, so no difference. So let's put a breakpoint at line number this. This is, we are still in demo 3 function, right? And I would like to show to you what the caller is actually passing to inc C function. Okay, it may come across as if we are passing only FF. What we are passing is actually 4 bytes of FF. Okay, So let's do that. And remember, when we do sign byte extension, the values don't change. Okay, that's the reason why we do move sign byte. Okay, all right. So let's run this thing. Continue. Okay, now I wanted to see what is the value of EAX register, or even the top of the stack, right? Because we pushed the arguments on the stack. So let's look at one word on top of the stack. Okay, here you go. You see FFFF. Even though we wanted to only call the caller with only FF, the assembly code actually has more logic than what your C code has. Automatically, your FF is extended to 4 bytes from 1 byte. And remember, FF means -1 in terms of integer value. And all FFFF is also -1 if you treat that as a signed data type. Okay. Therefore, we are passing this to the caller. And now we can get back to the inc C function. The inc C function is actually now going to take whatever the user has passed, right? That's going to be 8 plus EBB into EAX. And then he's going to only take the least significant byte. That's the reason why we are referring to AL. That means now we will be just taking the last byte, the least significant byte, which is FF, and we transfer that to a local variable. That's the EBB -4. And then again, the most important step is move ZBL. Okay, let's do that first. Let's put a breakpoint at this statement. Okay, let's continue. And now let's examine the status of the EAX register. Okay, because the caller has passed bunch of FFF, we have FFF here. Okay, but we are going to do the assembly statement, which is just going to take FF and then put all the leading 3 bytes to 0. That's the reason for move ZBL. Okay, let's run the move ZBL now. And we look at the state of EAX. As you can see here, now the EAX is only FF. The rest of the FFs disappeared because we did a move ZBL, okay, which is basically take the byte, only copy the least significant byte from EBB -4 into the EAX register, and the remaining 3 leading bytes are zeroed out. That's the reason for the Z. Z stands for zero out, okay, and that's all. So this is how the runtime handles C runtime in particular handles character type, and it automatically converts character type to integer type under the hood, and we understand hopefully how that is working. Okay, so that's all for the demo. Thank you very much.